Okay, if we can turn to page 22. So today, more of the same, but there's something a little different with dealing with multiple angles. We're going to solve for x without relying on identities, but relying on just inverse and division. So, but today will be the last new day of anything that's new. Tomorrow we'll do a full review. Thursday we'll do a full review. And Friday, the test will just be over solving equations. Okay, so just what we started covering last Thursday. Okay, so just solving equations. Yeah, you'll be given a sheet with all the identities, so much like the last quiz, identities at the top, and then unit circle, blank unit circle at the bottom, okay, and no calculators. Okay, no calculators. Test will be just 8 equations. Okay, solving 8 equations. Okay. So let's look at number 1, page 22. Okay, so there's a specific way that I want us to work through these types of problems. Okay. We're not going to worry about sum and difference, identity, trying to split this up. In fact, we're just going to focus on trying to get that 3x by itself. Okay, so the way we're going to do that is we're just going to take the inverse of both sides and just move that sign, inverse sign, to the other side. So we'll say 3x is equal to inverse sign of 1. Okay. Everybody good with this first step? We're taking the inverse sign of both sides. The left side is just going to wipe itself out. The right side is inverse sine of 1. So we understand what inverse sine of 1 means. All this is saying is, where are the angles where sine of theta is equal to 1? So pi over 2. Now here's what's different about this process. Okay. Oh, can you stay for a little bit, like 5-10 minutes, or do you have to go right now? Okay, I just want to just go through this with you so that, and then you can go in like 10 minutes if that's okay. So if I inverse sine of 1, sine of theta is equal to 1 at pi over 2. Now, what's happening is that we want the values between 0 and 2 pi, which we have right here, but we have to understand that we're going to eventually divide by 3. When we divide by 3, all those values are going to shrink. So what we need to do is we need to find coterminal angles beyond 2 pi, so that when they shrink, we have all the values between 0 and 2 pi. So we're going to have to find some coterminal angles, maybe more than what we need, so that we could just make sure that we have everything that's needed after all these values shrink. So the way we find coterminal angles is we're going to add 2 pi. So in this case, common denominator will be 2, so 4 pi over 2. So we're going to keep adding 4 pi over 2 so that we have more than what we need. Okay, so what will be the next value be? Okay, 5 pi over 2. Keep going. Okay, let's just do a few more just so that we make sure that we don't accidentally miss out on other ones. Next. Okay, one more. 17 pi over 2. Okay, it's probably way more than what we need, but we want x to be between 0 and 2 pi, and it's about to get divided by 3. Okay, any questions so far? All right. Dividing by 3 is same thing as what? By 1/3. Okay, that's what I prefer, just so that I deal with the complex fraction. It just feels easier to multiply by a fraction than dividing by a number, right? So the left side becomes just x. Okay, multiply each of these fractions here, I get pi over 6. 5 pi over 6. 9 pi over 6, which can reduce to be 3 pi over 2. Okay, so we only want the values between 0 and 2 pi. Do we have any of these that we should eliminate because it's outside? Okay, 17 over 6 is more than 2. What else? Yeah, 13 over 6 is more than 2 because we know 12 over 6 is 2, right? And 13 over 6 is slightly more than 2. So I like it when I have too many because if I eliminate one, that means I didn't accidentally miss on previous ones. Okay, so we're not going to rely on sum and difference identity. We're not relying on double angle identity. We're just relying on inverse trig and division. Okay. Okay, number 2. Yes.
How do you know you have to add
The reason why we have to add 2 pi is because we're anticipating the fact that all our values are going to shrink. So when we divide by 3, all those values are going to shrink. So we want way too many. We want more than we need so that when we shrink them, that we have all the values that we are potentially missing on. So that's why we have to go way past 2 pi. Okay. So the larger the number, the more we have to add, right? Because if we're shrinking by a fourth, then we may need more than even 3x. So we'll approach this the same way. We don't want to use double angle. We don't want to go through sum and difference. We're just going to move that cosine over to the other side, make it inverse cosine. Okay, so where is cosine equal to 1? Because that's what this means, right? Inverse cosine of 1 means where is cosine theta equal to 1? Okay, 0, 2 pi, but we want to go further out than that, right? So let's keep going. What's next? Yeah, let's just do more than what we need. Okay. How would you solve for x here? By 1/4. Get the left side to be just a clean x by itself. And after we multiply, we'll see which ones fall inside the interval. 2 pi over 4 is just pi over 2. 4 pi over 4 is just pi. 6 pi over 4 is just 3 pi over 2. 8 pi over 4 is just 2 pi. 10 pi over 4 is just 5 pi over 2. Okay, should we eliminate any of these choices? Okay. Anything else? How about 2 pi? Do we keep 2 pi? Because parentheses, right? Parentheses. So we keep the 0 because there's a bracket at 0, but we don't keep the 2 pi because we're not, there's a parentheses at 2 pi. We're not including 2 pi. Okay, any questions so far? Okay, number 3. Secant of 2x equals -2. We'll use a multiple angle strategy here. So we'll take the inverse of secant on both sides. Now, secant is the reciprocal of what? Cosine. So maybe we can just write this another way. Inverse secant of -2 is same thing as saying inverse cosine of -1/2. Okay. Or if we wanted to start at the beginning and say, okay, I just want to convert secant 2x to be cosine 2x equals -2. You can go, if I make it into a cosine, I didn't make that -2 a what? A negative, what's the reciprocal of -2? -1/2. Okay, so you could look at the problem and just start it this way and go directly from here. Right. So we prefer to use sine, cosine, tangent, think in terms of sine, cosine, tangent, because those just come more naturally to us because of unit circle values. Okay, so go from here, see if you can list out all the values where cosine is equal to -1/2. Go further out than initially, right? Add 2 pi, add a couple more terms, and then we can multiply by 1/2 and make sure that all of our solutions that we need, that we can find between our interval. Okay, cosine is negative which quadrants? Second and third, okay. Variations of pi over 3. Add 6 pi over 3 a couple of times to those measures. Okay, let's move the 2 over. I can multiply, or I see the numerator and denominator can just reduce, save me an extra step here. So pi over 3. Okay, do we keep all of these? What do we remove? Okay, any questions? Okay, 4, 5, and 6 is more review from previous days. So, but these multiple angle strategy will come up on the next page. So go ahead and go through 4, 5, and 6, and I'll follow up with the working it out behind you, so you guys can check your answers.
How'd you get the where it's like the step where you get your answers?
Oh, right here.
Yeah, how'd you get?
So you're good with 2 pi over 3 and 4 pi over 3.
Yeah.
So we know we have to divide by 2. So we know that when these shrink, we're going to be missing out on some solutions if we don't list out more. So I'm taking my original measures, and I'm finding coterminal angles. So I can always find coterminal angles by adding 2 pi. So I'm just matching common denominator. 2 pi is same thing as 6 pi over 3. So 2 pi over 3 plus 6 pi over 3 will give me 8 pi over 3. 6 pi over 3 plus 4 pi over 3 will give me 10 pi over 3. And then I just keep going. 8 pi over 3 plus 6 pi over 3 is 14 pi over 3. Yeah, so I just keep adding 2 pi to each of the terms so I can just extend out my problem a little bit more. So I'm just getting ready for the fact that all these values will shrink. Okay, try number 4. Okay, for number 4, I think we may have to go the common denominator route, because really we can't take a GCF of sine or cosine, but convert that tangent to be sine over cosine first. So let's go the common denominator route, see if that will get us somewhere. Okay, what can we do with that cosine squared plus sine squared? Make it 1, makes it a little bit easier to solve for cosine, right? That whole numerator can just become 1. Cross multiply. Okay, any questions with the steps and how I got to that cosine x equals 1/2? Yeah.
Why did you, so I understand when you put 1 under cosine, but how did you get,
From here to here?
yeah.
So I'm looking to add these fractions together. So to add fractions together, I need common denominator. So common denominator between 1 and cosine, it'll have to be cosine. So then I have to balance each fraction. I see the 1 is missing a cosine, so I need to multiply the top by cosine as well.
Okay.
Yes. Yep, you'll be given an identity sheet like your quiz, just with the unit circle. Yeah, it's basically like your quiz. Unit circle will be blank, just like, yeah. So you'll be given all the identities and all the trig ratios as well. Yeah. Okay, so where's cosine equal to 1/2? First and fourth, yep. Okay, number 5, rely on sum or difference identity to expand out that cosine. Okay. Anybody still need to look at number 4? Once you expand, then try to resolve any of the values that you can replace using unit circle values. Because it's asking for sine equals -1. So sine at power 2 sine of, yeah, so. Okay, any questions with 5? Yeah. Okay, take a look at number 6, 2 secant squared plus 2 tangent squared equals 14. Any thoughts as to how we can approach this problem? Yeah, convert one to the other, right? Either everything in terms of secant or everything in terms of tangent. Which do you think, which would you prefer to work in? Secant? Okay. I prefer to work in tangent, but secant works too. Just because tangent is something that we can see on the unit circle. But if you prefer secant, that's fine. I'm going to do it in terms of tangent, but we'll get the same answer either way. Okay, so I'm going to try to replace secant just because tangent is more familiar to me. So remember, if you look on your identity sheets or back of this packet, we have the identity here, 1 plus tangent squared Oh, sorry. All right, we have that identity, so there's no need to memorize it. You'll have that on your formula sheet. Combine like terms. So there's no need to have to do any factoring here. We can just try to get that tangent squared by itself and work our way down to something hopefully we can recognize on the unit circle. Okay, so where's tangent equal to √3/1? Variations of what? Yeah, all four quadrants, right? Okay, back page whenever you're ready. Okay, so for 7, 8, and 9, let's rely on the multiple angle method that we've been working with. Okay, so try to get 2x by itself, and then we can divide that out. Okay. All right, is anybody still looking at number 6? All right, so number 7 through 12, these have no boundaries for the values, so we have to include plus 2 pi n. Okay. So I'm not going to rely on double angle identity. I'm going to just try to get 2x by itself. So 5 by 2. Take the square root first. And do you recognize square root of 1/2? That's the same thing as what? √2/2. Okay. Okay, so we want to find out all the values where sine is equal to root 2 over 2. So variations of what? Pi over 4, yeah. Now we may have to go, now this is for all 4 quadrants, right? So we may have to go add quite a few because terms, because we got to divide by 2. So let's see if we can list them out. So pi over 4. I'm going to add 2 pi to each of these as well. So I'm going to add 8 pi over 4 to each of them because it's going to go once around past 2 pi. I'm just doing more than I think I need here. Okay, so of all these angles, I'm going to divide by 2, which is the same thing as multiply by 1/2. So multiply each of these fractions by 1/2. So pi over 4 times 1/2 will be pi over 8. So basically all the denominator will change to over 8. Okay, do any of these values not belong in our interval? Yeah, 17 over 8, that's more than 2, right? 16 over 8 is 2, so 17 over 8 is more than 2. And then we just have to include the plus 2 pi n at the end. Okay, same idea for 8. Use the multiple angle strategy. No, don't expand using double angle. All right, anybody still working on 7? No. Okay, try number 8, same idea. Sorry, I already moved that 2 over, so the 2 is not there anymore. Oh, sorry, the 2x is still there, okay. So list out all the values where cosine of theta is equal to negative root 3 over 2. Variations of pi over 6. Okay, deal with the 2, multiply by 1/2. Okay, 29 pi over 12 is more than 2. We know 24 over 12 is 2, so this is way past. So I always like to have one more than what I need, so I know I've covered all my potential solutions. Okay, try number 9. Get the 2x by itself, just like how you did 7 and 8. Everybody good with 8? Mm-hmm. Yep. Yep. Number 10 is a factoring problem. So bring everything over to one side, set equal to 0. Everything's in terms of cosecant already, so factor an easier problem, and then you can bring cosecant back in. Okay, let me know if there's any parts you want me to clarify. If something doesn't make sense, let me know. Okay, here we go with 9. So number 10, everything's already in terms of cosecant, so that's good. There's no need to convert any of the trig functions. We're already sitting with what we have that we need. So bring everything over to one side, factor an easier problem, bring cosecant back in. So what's another way to think about this? We can rewrite this as what? Cosecant equals -2, which means the same thing as saying what? Good. Sine equals -1/2, and sine is equal to -1, right? -1 flipped is still -1. So whenever I see secant and cosecant, I always want to get it in terms of something that feels more familiar to me, especially with unit circle values. Third and fourth quadrant, variations of pi over 6. Okay, let's finish off with 11 and 12. Actually, let's just do number 11. We can finish 12 tomorrow. So let's finish with 11. Okay, does anybody still need to look at number 10? Okay. Okay, what's tangent of pi? Just 0, right? So that's going to wipe out a bunch of terms for us. We should be able to get all the way down to in terms of sine and tangent, because the cosine of pi over 2 and tangent of pi will wipe out a bunch of things for us. And then once you're down to tangent minus sine, yesterday we knew that we could always get everything in terms of sine and cosine in the hopes that we can factor a GCF out so that we can get two expressions that each have its own trig function. So here we can factor a sine out. Set each piece equal to 0. Oh, 2 pi, not pi. All right, let me check your work. We'll pick up number 12 tomorrow. Tomorrow we'll do a practice worksheet. Thursday I'll do a practice Okay. I guess just because there's no, but because the n has that 2 pi n, that covered it already. I don't have to write it, but you did write it.
If you did write it,